Welcome to the 21st discussion of The Smart World Around Us, a podcast organized by Smart-EDU Hub. Today, we're diving into a really fascinating article by Catalin Vrabia called Converting Municipal Waste to Energy Through the Biomass Chain, a Key Technology for Environmental Issues in Smart Cities. We're going to break down how our cities can turn a massive problem into a powerful solution. And just so you know, a link to the full article is right there for you in the description below.
Okay, let's just dive right into this. Every single year, humanity faces a challenge that is, well, it's just staggering. That number you're looking at, 1.3 billion tons, that's how much food gets wasted across the globe each year. And that's a huge part of the waste our cities have to deal with.
But what if we've been looking at this mountain of waste all wrong? What if we stop seeing it as just, garbage that needs to be buried and start seeing it for what it really could be, an absolutely incredible, untapped source of energy? To solve this, first we've got to understand the problem itself. Our cities are generating these immense amounts of what's called municipal solid waste, or MSW for short. And the real key to unlocking its potential is to understand what it's actually made of.
And this is where it gets really interesting. For a lot of cities, take Bucharest for example, the makeup of this waste is pretty surprising. Almost 80% of it is organic. Yeah, we're talking food scraps, paper, wood, all materials that have incredible stored energy just waiting to be released.
So the big question is, how do we unlock all that potential? How do we take that pile of organic leftovers and turn it into something that can actually power our homes and our cars? Well, the answer lies in a pretty remarkable biological process.
The answer is biogas. It's a renewable fuel that's created by, essentially, digesting our organic waste. And the really cool part is that it's considered CO2 neutral. That's because the carbon it releases was only recently pulled out of the atmosphere by plants. So unlike fossil fuels, it's not adding new carbon. It's just part of a natural closed-loop system.
And this explains the process perfectly. Just think of a biogas plant as a city's giant mechanical stomach. You feed it organic waste, and inside a big, sealed, oxygen-free tank, bacteria get to work and break it all down. And what comes out? Two incredibly valuable things: clean, renewable biogas for energy and a nutrient-rich biofertilizer that can help grow more food. It's a perfect circle.
Of course, getting from your kitchen trash can to the city's power grid requires a pretty complex system. This whole process is the waste-to-energy supply chain, and it's a carefully planned journey for our trash.
This supply chain is really the logistical backbone that makes the entire concept possible. It all kicks off with collection, then it moves through storage and transport, and it all ends at the conversion plant, where the real transformation happens. Every single step has to work together seamlessly. Now, this isn't just some theory on a whiteboard. Let's look at some pioneering cities across Europe that are already putting this into practice with absolutely incredible results. They're proving this is a real solution for the modern city.
For instance, take Bergen, Norway. Get this, they've pretty much eliminated garbage trucks from the city center. Instead, they use this massive underground vacuum system that just sucks 30 tons of waste a day through pipes. It's the kind of futuristic stuff you'd see in a movie, but it's happening right now.
Then you've got Tønsberg, also in Norway, which has created this perfect loop. They collect food waste from over 1 million people, turn it into biogas to fuel their public buses, and then the leftover biofertilizer goes to local farms to grow more food. I mean, today's waste is literally fueling tomorrow's transport and helping grow next week's meals.
Hopping over to London, a single biogas plant there is taking what the city throws away and turning it into a massive amount of electricity. We're talking nearly 40,000 megawatt hours. That is enough clean, renewable power for about 2,000 homes, all from our leftovers.
And check this out. In Barcelona, you've got this fantastic example of a public-private partnership. The city is working with the car company Seat to convert organic waste into biomethane, a fuel that's so clean they're using it to power their test vehicles. That's innovation in action.
So these success stories are just amazing. And it kind of begs the question, right? If this technology is so effective, why isn't every city on Earth doing it? Well, the path forward, as it turns out, has both some big challenges and some massive opportunities.
This chart really highlights the gap. I mean, it shows a huge difference in adoption across Europe. You've got countries like Germany, who jumped on this early and now have over 10,000 plants, while other places have, well, they've barely even started.
And here's the trade-off. The challenges, they're significant. These projects cost a lot of money up front. The logistics are really complex, and you absolutely need the public and politicians to get on board. But the rewards on the other side,
They're immeasurable. We're talking cleaner cities, less pollution, a local renewable energy source, and a truly circular economy. So, the potential is just sitting there right in our garbage bins. Every scrap of food we toss out isn't just waste, it's a missed opportunity for fuel, for power, and for a cleaner future. It's really a choice that our cities have to make. And that pretty much concludes our look into this topic. Thank you so much for joining us. Please like and subscribe to the Smart-EDU Hub channel so you can be the first to enjoy our new podcasts. And remember, you can find a link to the full article by Catalin Vrabi right in the description below. Goodbye for now.